Cloud.
Okay, I see it now.
All right, let's do it.
So our presentation is on smart grids. What are smart grids? A smart grid is a system by which electrical energy is efficiently created and distributed in a particular area. It contains power plants, electrical lines, utilities, and includes a central hub by which all electrical energy is distributed and monitored. How do they work? In the current system, the power grid is a one-way transfer of electricity from the plants to the grid to the outputs, the utilities. A smart grid is a two-way exchange of energy and information by which each utility or household only takes the amount of energy they need and gives the rest back to the grid. This allows the grid to move energy more autonomously and efficiently. This is a data movement chart. So smart grids utilize a combined two-way flow of energy and information about energy consumption. So as seen here in the chart, the dotted lines are information flow and the solid lines are energy flow. And it shows that energy flow and information flow are two-way given and received from the utilities.
All right, so how do smart grids affect global climate change and energy usage? Well, firstly, the systems allow for renewable energy sources to be implemented directly into the grid system. Because each utility shares power to each other, you can implement any kind of energy system you want, and the power can be distributed in any way. Secondly, the grid can determine to use these renewable sources more than current fossil fuel sources. So if we start implementing more renewable sources, and we can still keep in the fossil fuel sources, we can distribute the energy appropriately and use those new renewable sources efficiently. Thirdly, it allows for more efficient transmission of power, which reduces overall use. Because we have energy going to each utility, the utility only takes what it needs and then gives it back to the grid. Each utility shares power and the right amount is used, and so you don't have to produce as much. And so what are the benefits of all this? Well, as we were just saying, it reduces energy consumption and creation because each utility can share energy with each other. And secondly, because of the way that information is tracked about energy usage, we can have improved and more accurate billing and customer service from energy companies because each utility's power usage is shared. And thirdly, we can have an improved integration of renewable energy sources, as we said, because it's a grid, these things can be easily added. And lastly, we have more resilience to natural disasters and damages. Because everything shares energy with each other, if one particular line is cut in the current power grid, we can have a huge outage, but in a smart grid, this is less of a problem. And so here's just some visuals of the kind of benefits we're talking about. So here's just a comparison of what a smart grid is versus our current grid. So we would have many smaller power producers versus a few large sources of power. That's more about the reliability. And it's decentralized and it's less reliant on central sources. It'll include small-scale transmission and regional supply compensation versus large power lines and pipelines. And of course, information power flow, both directions. That's the main difference. And each utility, of course, this is a big difference too. Each utility will give power back and information back in the entire system.
All right, so how can this process of changing over to smart grids be accomplished? Well, there are currently multiple attempts to integrate the smart grid into the current energy grid, mainly by monitoring current data flow patterns and encouraging smart energy appliances and technologies. This process can be continued until every citizen willingly changes over to utilities only run by the smart grid. So New Jersey, one state, for example, is doing this by incentivizing consumers to buy smarter energy technologies and reducing their cost of energy if they buy from smart energy sources. Opposingly, the entire current structure could be torn down in chunks where a smart hub per region is erected and the utilities are built up back around it. Think of this as how they repair highways in chunks. They lane block off a few lanes, repair it, and move on to the next section. This could ultimately cause some traffic jams energy wise, but it's a interesting trade-off. What are some valid criticisms of the smart grid? The first is the second law of thermodynamics. Each time the electrical energy is put back into the system, it gives off more and more heat and becomes weaker. So when the energy is created, goes to a home, goes to another home, goes to a utility, goes back to a power plant, it's ultimately weaker than when it started, and it's given off a lot of heat. And that heat can become a major problem. The heat generated by the smart grid would be such that anything that's not built to withstand smart grid level heat will probably take damage because of it, and smart grid systems themselves can be damaged from the unbelievable amount of heat that can be generated. The second problem is automation. The smart grid wouldn't need for blue collar or skilled labor jobs and would rely heavily on electrical engineers and computer engineers and the such like that, and would cut out a decent sized chunk of an industry workforce that is very big into that base. The grid is said to be more energy secure, but the external movement of personal data to a public system always comes at some risk. We've seen recently in the past with massive data breaches at places like Facebook and Google, any type of information you are putting out to a public system, no matter how much information you think it's giving of your life, it may always be too much. And the lastly, not all places have equal access to smart grid technology. Some poor countries or third world nations don't have access to any electricity at all, and many believe that it's more important to get any form of electricity to those places than to fix our own current usable first world energy system. All right. These are our citations. Thank you very much for listening to our presentation on smart grids. Bye.